Hello students, today we will see inverse transform of logarithmic functions and inverse functions. We have the property we have used in previous examples also, that Laplace of t into f of t. I am writing Laplace of t into f of t. That is equal to minus d by ds of Laplace of f of t. This is equal to minus d by ds. Suppose Laplace of f of t is phi of s. Right? Laplace of f of t is phi of s. So Laplace of t into f of t is equal to minus d by ds of phi of s, or we can write here minus notation phi dash of s. This is Laplace transform of t into f of t. Okay, now from this I want to derive a formula how to find inverse of logarithmic functions and inverse functions. So from this I can write, I'm going to change the sign, minus phi dash of s is equal to Laplace transform of t into f of t. So if I take inverse on both sides, right, so L inverse of minus phi dash of s is equal to t into f of t, right, t into f of t. What is f of t? F of t is, we know that f of t is L inverse of phi of s, right, minus phi dash of s. So from this it is clear that the formula that L inverse of phi of s is equal to 1 by t into L inverse of minus phi dash of s, or you can take it minus outside, minus 1 by t L inverse of phi dash of s, means I am using differentiation of phi of s to find L inverse of phi of s, and we have to use this in logarithmic function and inverse functions. If the question involve logarithmic functions or inverse function, using this formula we can find its inverse Laplace transform. Clear? So you have to remember these results. Either you can remember this result or you can remember this result. Both are one and the same. Let us write working rule for this. Working procedure for problems. Step 1. In case of logarithmic functions, we apply the properties of logarithm. We have to apply the properties of logarithm. What are the properties of logarithm? Log of m by n is there, then you can write log of m minus log of n. If log of m into n is there, use the property that log of m plus log of n. If log of m raised to n is there, you can write n into log m. And wherever required, log of 1 to the base e is equal to 0. So these are the properties of logarithm we have to use in case of logarithmic functions. Then we have to differentiate with respect to s then we have to differentiate with respect to s to obtain phi dash of s. Right. Once we got phi dash of x, we have to multiply step 2. We then multiply by -1 and take inverse on both sides. Alright, this is the second step. Step number 3, in case of inverse functions, means cot inverse of some function of s, or you can say tan inverse of some function of s, or tan h inverse some function of s. If this type of functions are there, then we simply differentiate the given phi of s and we use the result L inverse of minus f dash of s is equal to t into, this is f of t. Right? We will use this result and directly you will get f of t. Let us solve few examples on this. First example, suppose the question is find the inverse Laplace transform of the following functions. Number 1, log of s square plus 4 upon s square plus 9. Okay, this is the example. I am going to consider this is phi of s log of s square plus 4 upon s square plus 9. Now if log is there, as we have discussed, use the property of logarithm. Log of s square plus 4 minus log of s square plus 9. After using the property of logarithm, differentiating phi of s with respect to s, left hand side phi dash of s is equal to, in the right hand side, log of this part. So as we know, the derivative of logarithm, log x will be 1 by x, and into derivative of s square plus 4, which is a chain rule, with respect to s is 2s minus 1 upon s square plus 9 into 2s. Again derivative of s square plus 9, which is 2s. So this is the differentiation of phi of s. After differentiating, we have to take inverse Laplace transform. So taking inverse transform on both sides, before that you can do one step. You can multiply with multiply by minus 1, we get, so if I multiply both the sides by minus 1, this term will be minus 2s upon s square plus 4, and this term will be plus 2s upon s square plus 9. This is second step. Now taking inverse transform on both sides, L inverse of minus phi dash of s is equal to L inverse of minus 2s upon s square plus 4 plus 2s upon s square plus 9. In the right hand side you can split the inverse. There are two terms. You can take constant also outside. So minus 2 is constant. L inverse of s upon s square plus 4 is 2 square, plus 2 is constant. L inverse of s upon s square plus 9 is 3 square. So this is equal to minus 2 into L inverse of s upon s square plus 2 square is cos of 2t plus 2. L inverse of s upon s square plus 3 square, this is equal to cos of 3t. So this is L inverse of minus phi dash of s. Use the formula. We know that L inverse of minus phi dash of s is equal to t into f of t. Right. So this I am going to write in the left hand side, that minus 2 I am taking common. So cos of 2t minus cos of 3t is equal to t into f of t. So simply your f of t is, I'll write here only. So f of t is 1 by t, right? Here you can take minus inside and 2 outside. So 2 times minus inside. So this will be plus cos 3t minus cos of 2t. Student, आप खुद simplify करो और ये answer check करो. This is the first example. In this example, log is there, so we have used the method. We are using differentiation of phi of s to get the answer. Let us solve next sum. Suppose we want L inverse of tan H inverse S, right? This is again one of the important sum. But here, student, we must know that the formula tan H inverse of x, this is from inverse hyperbolic function, 1 by 2 log of 1 plus x upon 1 minus x. This is the formula. 1 by 2 log of 1 plus x upon 1 minus x. This is tan H inverse x. 1 by 2 log of 1 plus x upon 1 minus x. So this formula I am going to use over here. Same in terms of s I am writing. So I'm going to consider my phi of s is tan H inverse of s. By using the formula 1 by 2 log of 1 plus s upon 1 minus s. 1 by 2. Use the property of logarithm. Log of 1 plus s minus log of 1 minus s. Now differentiating with respect to phi of s with respect to s. So derivative phi dash of s, 1 by 2 is constant. Derivative of log of 1 plus s is 1 upon 1 plus s minus. Derivative of this term is log of 1 minus s into derivative of 1 minus s with respect to s. So 1 ka to 0. and s का 1. So this is there. So 1 by 2 into 1 upon, here 1 plus s, this minus minus becomes plus 1 upon 1 minus s. So this is equal to 1 by 2 into 1 upon 1 plus s को आप लिखो s plus 1, right? And here also 1 minus s है ना, मुझे s minus 1 लिखना है, तो आप माइनस साइन यहाँ पे कॉमन ले सकते हो ऐसे बाहर, माइनस, और ये यहाँ पे प्लस जो था वो माइनस हो गया. सो s minus 1, जो माइनस यहाँ पे आता है डिनोमिनेटर और न्यूमरेटर में जाएगा. सो दिस इज द डेरिवेटिव ऑफ phi of s. Now taking इनवर्स ट्रांसफॉर्म ऑन बोथ साइड, उसके पहले एक स्टेप कर देते हैं, इसको -1 से मल्टीप्लाई कर देते हैं. सेकेंड स्टेप, मल्टीप्लाई बाय -1 वी गेट माइनस phi dash of s इज इक्वल टू 1 by 2. ये टर्म नेगेटिव होगा माइनस से मल्टीप्लाई करने से, और ये टर्म पॉजिटिव होगा. ठीक है. सो 1 by 2 यू कैन राइट इट लाइक दिस ऑल्सो. 1 upon s minus 1, ये पॉजिटिव टर्म फर्स्ट, बाद में नेगेटिव टर्म. नाउ टेकिंग इनवर्स लैप्लास ट्रांसफॉर्म, टेकिंग इनवर्स ट्रांसफॉर्म on both sides, see what will happen if I take inverse. Remember this 1 by 2, 1 upon s minus 1 minus 1 upon s plus 1. We have the step one by 2, 1 upon s minus 1 minus 1 upon s plus 1. Okay, so I'm taking inverse Laplace transform on both sides, so this will be L inverse of minus phi dash of s is equal to 1 by 2 is constant, L inverse of 1 upon s minus 1 minus L inverse of 1 upon s plus 1. So as you know, 1 by 2 and L inverse of 1 upon s minus 1, by using the formula it is e to the power a is 1, e to the power 1t, that is t, minus here a is again 1, 1 upon s plus 1, so e to the power minus t. So this is the L inverse of minus phi dash of s. Then we know the formula. We know that L inverse of minus phi dash of s is equal to t into f of t. So this is 1 by 2 e to the power t minus e to the power minus t is equal to t into f of t. Therefore f of t is equal to 1 by 2t e to the power t minus e to the power minus t. तो ये मेरा f of t है. अगर इस f of t का हम लाप्लास लेंगे तो हमें गिवन क्वेश्चन मिलेगा. गिवन क्वेश्चन मतलब इफ आई टेक लाप्लास ऑफ दिस यू विल गेट tan h inverse of s, and if you find inverse Laplace transform of tan h inverse of s, we will get this term. This type is important. Let us solve few examples on this. Suppose the question is, I want L inverse of tan inverse 2 by s. Okay. So L inverse of tan inverse 2 by s. So I'm going to consider phi of s tan inverse 2 by s, right? Then if the question is directly tan inverse or cot inverse or tan h inverse, we have to differentiate. We have to differentiate with respect to s directly. So differentiating with respect to s. So derivative is phi dash of s is equal to, as you know, d by dx of tan inverse some f of x is there, 1 upon 1 plus f of x bracket square into derivative of f of x, that is f dash of x. So here f of x, that is a function of x, here this is a function of s, 2 by s. So 1 upon 1 plus square of this, so 4 upon s square into derivative of 2 by s. 1 upon LCM ले लो, s square plus 4 upon s square into derivative of this 1 by s का derivative minus 1 by s square, this 2 is constant, so minus 2 by s square. So ये s square यहाँ पे कैंसिल होगा, आप न्यूमरेटर में लेके जाके भी कैंसिल कर सकते हो. So finally minus 2 upon s square plus 4, this is phi dash of s, minus 2 upon s square plus 4, multiplying by minus 1, we get. So minus phi dash of s is equal to 2 upon s square plus 4 is 2 square. Now next step is taking inverse, transform on both sides. On both sides. So L inverse of minus phi dash of s is equal to L inverse of 2 upon s square plus 2 square. This is 2 is constant and L inverse of 1 upon s square plus 2 square is 1 by 2 and sine of 2t, 2 gets cancelled. So this is sine of 2t simply. Right, and this is equal to t into f of t. That sine of 2t is equal to t into f of t. So answer is f of t is equal to, this is our answer, 1 by t sine 2t. 1 by t sine 2t. So if you take inverse of this, you will get tan inverse 2 by s, and if you take L inverse on this, you will get 1 by t sine of 2t. Next example. Suppose the example is, इसी एग्जाम्पल को थोड़ा एक्सटेंड करते हैं. Suppose I want L inverse of tan inverse 2 by s square. Important example है, exam point of view. Okay. Let phi of s is equal to tan inverse 2 by s square, differentiating with respect to s, 1 upon 1 plus square of this 4 upon s raised to 4 into derivative of 2 by s square. This is equal to s raised to 4 plus 4, derivative of 2 by s square is minus 4 by s cube, right? This is s raised to minus 2 will come in the numerator and s raised to minus 2 का होगा minus 2 into s raised to minus 3. So here one term is cancelled, so minus 4s upon s cube is cancelled here. So minus 4s upon s raised to 4 plus 4. So student, we have this minus 4s upon s raised to 4 plus 4. Okay. So now यहाँ पे s raised to 4 आ चुका है. कंप्लीटिंग द स्क्वायर से नहीं होने वाला है. ओके. सो कंप्लीटिंग द स्क्वायर में कुछ हमें ऐड करना पड़ेगा, सब्ट्रैक्ट करना पड़ेगा. सो वी हैव टू फोकस ऑन दिस फर्स्ट. सो आई एम गोइंग टू कंसिडर मल्टीप्लाइंग बाय minus 1. सेकेंड स्टेप. Multiply by minus 1, we get minus phi dash of s is equal to 4s upon s raised to 4 plus 4. Okay. So now taking inverse transform on both sides, we get. So I'm going to take inverse transform of both sides minus L inverse of minus phi dash of s is equal to L inverse of 4s upon s raised to 4 plus 4. इसे इक्वेशन नंबर 1 दे देता हूं मैं. Okay. So now s raised to 4 plus 4 जो है इसका L इनवर्स निकालना है. ओके. तो यहां पे हमें फोकस करना पड़ेगा. लेट अस सी. सो आई एम गोइंग टू स्टार्ट सम एडजस्टमेंट फॉर दिस टर्म s raised to 4 plus 4. s raised to 4 plus 2s square plus 4 minus 2s square. Okay. So you can write 4s square ले लो. s raised to 4 plus 4s square plus 4 and minus 4s square. So these two terms are there. I am adding plus 4s square and minus 4s square. Now completing the square, right? Completing the square. So first three terms, from first three terms you can write s square plus 2 bracket square minus. From this you can write 2s bracket square. So this is the adjustment that we are going to do in the denominator of this s square plus 4. After this you can use the formula, that is a square minus b square is equal to a minus b into a plus b. This formula I am going to use. So this will be s square plus 2 minus 2s and s square plus 2 plus 2s. So I am going to write it like this: s square minus 2s plus 2 and s square plus 2s plus 2. So जो टर्म यहाँ पे डिनोमिनेटर में ये टर्म है, इसकी जगह पे हमें ये दो फैक्टर्स लिखना है. ओके. So you note down this. So by equation 1, L inverse of minus phi dash of s is equal to L inverse of 4s upon s raised to 4 plus 4. This step is there. And in the denominator, that s raised to 4 plus 4 is there. So in place of that I am going to write two factors as we have discussed: s square minus 2s plus 2 and s square plus 2s plus 2. Okay. Still my problem is not solved, my dear student. यहाँ पे two terms are there, two factors are there, and both are in the denominator. We need to separate it. One separate method is there that we will discuss in the next few upcoming videos, that use of partial fraction method. So here I am not going to introduce that concept of partial fraction method. I am doing some adjustment. This type of adjustment if you do, so it is nothing but a partial fraction only. Okay. So यहाँ पे जो न्यूमरेटर में जो 4s है उसको हमें we can write it like this. 4s is equal to s square plus 2s plus 2 minus s square plus 2s and minus 2. Okay, so it is nothing but some adjustment part is there here. Plus s square cancel with this minus s square and plus 2 cancels with this minus 2. So here I am going to use bracket, take minus sign common, so s square, then this will be minus 2s and this is plus 2. So जो 4s न्यूमरेटर जो है उसको हम ऐसा लिख सकते हैं, right? We can write it like this. So by this equation 2, suppose by equation 2 L inverse of minus phi dash of s is equal to, यहाँ पे जो न्यूमरेटर में 4s है उसे हमें लिखना है s square plus 2s plus 2 minus s square minus 2s plus 2 whole divided by s square minus 2s plus 2 and s square plus 2s plus 2. Now we will divide it separately. देखो ये जो फर्स्ट टर्म है, ये जो फैक्टर है डिवाइडेड बाय ये दोनों फैक्टर, तो ये यहां से कैंसिल हो जाएगा, राइट? यहां से कैंसिल होगा, सो यू विल गेट 1 इन द न्यूमरेटर and s square minus 2s plus 2 in the denominator minus, इसको इसके साथ कैंसिल करो, सेपरेट डिवाइड करेंगे तो ये यहाँ पे कैंसिल होगा. सो 1 अपॉन s square plus 2s plus 2. मतलब अगर हम इसका LCM लेंगे, LCM क्रॉस मल्टीप्लाई करेंगे तो हमें 4s मिल जाता है, राइट? 4s. दिस इज जस्ट द एडजस्टमेंट. Now we have to use the previous method, completing the square. So here we can write this denominator as s minus 1 bracket square. So देखो simplify करो, s square minus 2s plus 1, but यहाँ पे तो 2 है तो हम लिखेंगे इसे यहाँ पे plus 1 minus here s plus 1 bracket square, तो s square plus 2s plus 1, but यहाँ पे तो 2 है तो plus 1. Now you can use the property. You can use the property. Here value of a is, you can separate L inverse of 1 upon s minus 1 bracket square plus 1 plus minus is there L inverse of 1 upon s plus 1 bracket square plus 1. So यहाँ पे a का वैल्यू 1 है और यहाँ पे भी a का वैल्यू भी 1 है, यहाँ पे भी a का वैल्यू 1 है. सो दिस इज phi ऑफ s माइनस a, तो ये आ जाएगा e टू द पावर at. a का वैल्यू 1 है, सो दिस इज e टू द पावर t and L inverse of 1 upon s square plus 1. Here e to the power minus t into L inverse of 1 upon s square plus 1. So this is e to the power t into sin t minus e to the power minus t into sin t. Right? e to the power t into sin t minus e to the power minus t into sin t. तो ये मेरा है आंसर L inverse of minus phi dash of s. Please note down. We have the step L inverse of minus phi dash of s is equal to e to the power t into sin t minus e to the power minus t into sin t. You can take it common. So e to the power t minus e to the power minus t into sin t. This is now by formula L inverse of minus phi dash of s is equal to t into f of t. So this e to the power t minus e to the power minus t into sine t is equal to t into f of t. So f of t is equal to 1 by t e to the power t minus e to the power minus t into sine t. जैसे और भी सिंप्लीफिकेशन पॉसिबल है, तो आप एक काम कर सकते हो, 2 से मल्टीप्लाई करो एंड 2 से डिवाइड करो. अगर क्वेश्चन प्रूव दैट आया तो ये हमें करना पड़ेगा. ये जो फॉर्मूला बन जाता है वो है साइन हाइपरबोलिक टी का. सो माय डियर स्टूडेंट, 2 टाइम्स साइन एच टी इंटू साइन टी होल डिवाइडेड बाय टी, ये जो सम है इसका अगर हम लाप्लास लेते हैं तो हमें मिल जाता है tan इनवर्स 2 बाय एस स्क्वायर फाइनली. और अगर हम इसका इनवर्स लाप्लास लेते हैं तो हमें मिल जाता है 2 sin एच टी साइन टी अपॉन टी. सो दिस इज वन ऑफ द इम्पॉर्टेंट सम ऑफ दिस टाइप. ओके, लेट अस सॉल्व अगेन few examples. Suppose I want L inverse of cot inverse of s plus 3 upon 2, right? So let us consider, you know the procedure. Let phi of s is equal to cot inverse s plus 3 by 2. Differentiate करें से, right? Differentiating with respect to s. Okay. So derivative of cot inverse, as you know, d by dx of cot inverse f of x is there. So minus 1 upon 1 plus f of x bracket square into derivative of this f of x, which is f dash of x. ठीक है. तो यहाँ पे जो मेरा f of x है वो है s के टर्म में s plus 3 by 2. So minus phi dash of s derivative left hand side minus 1 upon 1 plus s plus 3 by 2 bracket square into d by ds of s plus 3 by 2. Okay, so this is equal to minus 1 upon 1 plus s plus 3 bracket square by 4 और इसका डेरिवेटिव होगा s का होगा 1 and 3 का होगा 0. So this will be simply 1 by 2. So LCM ले लो, यहाँ पे ये 4 ऊपर जाएगा. Minus 4 upon 1 plus s plus 3 bracket square into 1 by 2, यहाँ पे कैंसिल हुआ. So phi dash of s is equal to minus 2 upon 1 plus s plus 3 bracket square. Okay. So you can multiply by minus 1. So we get minus phi dash of s is equal to 2 upon 1 plus s plus 3 bracket square. इसका इनवर्स लेना है, तो ऑलरेडी ये कंप्लीटिंग द स्क्वायर फॉर्म में है, तो इसे वापस हमें इस ब्रैकेट को ओपन नहीं करना है, राइट? सो टेकिंग इनवर्स ट्रांसफॉर्म on both sides, L inverse of minus phi dash of s is equal to 2 is constant, L inverse of 1 upon 1 plus s plus 3 bracket square. So this is 2 times, यहाँ पे ये phi of s plus a टाइप है, तो a का वैल्यू 3 है, so e to the power minus 3t and L inverse of 1 upon 1 plus s square. तो ये तो साइन बन गया. So 2 times e to the power minus 3t into sin t, and this is equal to, by formula we know that this is equal to t into f of t. So final answer is answer of this question is f of t is equal to 2 by t, right? 2 by t e to the power minus 3t into sin t. तो ये मेरा फाइनल आंसर है. This type is important, so I am taking more number of sums, right? Please, definite question hai ye. Suppose the question is we want L inverse of log of s square plus 1 upon s into s plus 1. इसका आंसर बाद में हम यहाँ पे आंसर लिखेंगे इसका. ओके, लेट अस सी. फर्स्ट ऑफ ऑल यू हैव टू कंसिडर phi of s is equal to log of s square plus 1 s into s plus 1. As we have discussed, whenever you will see logarithm, so we have to use properties of logarithm first. Okay, so log of m by n property use karo. This is equal to log of s square plus 1 minus log of s into s plus 1. So this is log of s square plus 1. यहाँ पे log of m into log of n का property use करो. This is equal to log of m मतलब s plus log of s plus 1. ये जो माइनस साइन है ब्रैकेट के अंदर ओपन करो. So log of s square plus 1 minus log s minus log of s plus 1, right? तो ये हो गया मेरा phi of s. So differentiating phi of s with respect to s. So phi dash of s is equal to इसका डेरिवेटिव log का just now हमने बहुत बार कर चुके हैं 1 upon s square plus 1 into 2s minus इसका डेरिवेटिव 1 by s minus इसका डेरिवेटिव 1 upon s plus 1. So this is after simplification 2 s upon s square plus 1 minus 1 by s minus 1 upon s plus 1. So now take multiply by minus 1 and taking inverse Laplace transform. So we get multiplying by minus 1 and taking inverse Laplace transform, we get L inverse of minus phi dash of s. I am doing both the steps simultaneously. So L inverse of ये जो multiply by minus 1 करेंगे तो ये minus हो जाएगा minus 2 s upon s square plus 1. ये माइनस का प्लस होगा, ये माइनस का प्लस होगा. So this is equal to minus 2 कॉमन ले लो, right? And L inverse of this term is cos t plus इसका जो L inverse है वो 1 और इसका जो L inverse है e to the power minus t. So this is minus 2 cos t plus 1 plus e to the power minus t. And by formula, L inverse of minus phi dash of s is equal to t into f of t. So f of t is equal to, अब इसका हमें आंसर मिल गया, f of t is equal to 1 by t, right? 1 by t and ये टर्म आ जाएगा minus 2 cos t plus 1 plus e to the power minus t. So this is the answer of this question. Let us solve one more example. Suppose we want L inverse of s square plus a square upon under root some s plus b is there. Okay, इसका आंसर हमें निकालना है. Logarithm is there, same procedure. Let phi of s is equal to, sorry, log is here. So log of s square plus a square upon under root s plus b, right? So differentiating, so phi dash of s is equal to, before differentiation I am going to use the property of logarithm, minus log of under root of s plus b. So this can be written as log of s square plus a square. log का जो second property है अंडर रूट एस प्लस बी को हम एस प्लस बी रेज टू हाफ भी लिख सकते हैं, राइट। और ये जो हाफ है ये आगे आ सकता है लॉग का प्रॉपर्टी लगाकर। हमें इसको डिफरेंशिएट करना है, तो इसका डेरिवेटिव होगा 1 अपॉन एस स्क्वायर प्लस ए स्क्वायर इंटू 2s माइनस 1/2, इसका डेरिवेटिव होगा 1 अपॉन एस प्लस बी इंटू 1. So if you write it properly, so this will be 2s upon s square plus a square minus 1/2 into s plus b. ये मेरा phi dash of s है, clear? So multiply by -1. So minus phi dash of s is equal to, ये वाला टर्म नेगेटिव होगा, so s upon s square plus a square, और ये टर्म पॉजिटिव होगा 1 upon s plus b. Now taking inverse Laplace, so -2, and L inverse of this term is cos of 80